So we will talk about LTE in this module. The next module is LTE Advanced. Okay. So we'll talk about what is the key features of LTE and OFDMA and SC-FDMA, evolved packet core, frame structure, and resource allocation, how things are done in LTE. Key features. First of all, LTE stands for long-term evolution. Okay, long-term evolution. Now that long-term is now past because LTE is already here. But this was the word that was invented back in 2007. Right, long-term evolution. In the long term, we will get there. And the same group, 3GPP, that does the 3G. The name is still 3GPP, but it is doing all the future work on telephony networks. 3GPP2 is no longer active. So everybody goes to 3GPP. This is like IEEE and so on and so forth. It's the organization. So 3GPP has every year a new release of the telephone network. And so the release 8, which came out in 2009, is called LTE. Okay, I think right now they are in a release 12 or 13. So this is again little bit. And it is 3.9G because it is not 4G. This is called pre-4G technology. But by some carriers it is sold as 4G. But 4G has a very strict definition from the ITU. And there is a spec that you can download called M.2134-2008. Which defines what is 4G. All right. So LTE does not satisfy that spec. And the sole purpose of LTE Advanced is to satisfy that spec. And therefore, LTE Advanced, when we come to that in the next module, is 4G. So what is an LTE did? LTE runs at many different bands. And why all these different bands? Because just historical reason and country reason. Basically, some countries have only 700 megahertz, some have 1500, some have 1700, some have 2100, some have 2600. And I think 2100 is bolded here because that is the United States. Flexible bandwidth. And then basically depending upon how many bits per hertz you can get and how many hertz you can get, because each of these bands has a different bits available to you. You can get from 1.4 megahertz all the way to 20 megahertz. Okay, so that's a very good question. The question is, when you get 20 megahertz, does each user get 20 megahertz or the whole network gets 20 megahertz? The answer is it's the whole network, but I can give it to one user. So there is no, I mean, I can give 10 megahertz to, well, thing is everything is variable now. Previously, we had adaptive modulation. Now we have adaptive allocation. So it's not that everybody has to get 10 kilobits at 10 kilohertz. I can give you the whole thing. If there's no other user, or I just don't care for the other user. I'm just telling you just as a joke. But there is no strict boundary of users. Okay, so there's nothing fixed anymore. Everything is adaptive. And it uses both FDD and TDD. And there is a whole debate we can go on FDD and TDD, by the way. FDD means that we have to spend half of our frequency for nothing. Because if nobody is doing uploading, which most of us are not, most of us are doing downloading only, then what is that up frequency is doing? Half of the up frequency, right? So FDD is wasteful, particularly for data. For voice, basically, we talk 50% of the time and listen 50% of the time. So there is 50-50 traffic. But for data, the traffic is not 50-50, up and down. It's a lot more down than up. Right? So TDD is better. However, TDD has its own problem that we'll see later on. So second thing is, it says that both paired and unpaired spectrum can be used. So what is a paired spectrum? Paired spectrum is required for FDD. For FDD, you need down and you need equal amount up. That is paired spectrum. Remember, you saw that 900 to 950 megahertz and 45 megahertz away, similar bandwidth there was, right, in GSM. So that is paired spectrum. For TDD, you don't need paired. So it can work with both paired and unpaired spectrum. It can use 4x4 MIMO. It can also use multi-user collaborative MIMO. Yeah.
Sorry, 4x4 MIMO. It's for the uplink or the downlink of both.
Okay, when you say 4x4, it means 4 on both ends.
Yeah, I mean, for the uplink or the...
Okay, hold on. If you have 4 antennas, you will use it for both. If you have 4 antennas, you will use it for both. Thing is, if you have 1 antenna, use it for both. The thing is, you don't have a separate transmit antenna and receive antenna. So what you can do is you could have more antennas and not use them, in the sense that when you do the processing, for processing, you somehow, cut it down. So receiving, the poor guys who are poor and they cannot afford some expensive receiving thing, they may, something like that. So that variation is possible. But yes, 4x4 is for both. Now, multi-user collaborative MIMO, I have talked about it in this class, so I'm not going to explain more. But if you remember, when we talked about OFDMA, we talked about how 2 users, they not knowing each other, can still talk in parallel to the single base station. That is called multi-user collaborative MIMO. That 2 users are collaborating without knowing actually. They're collaborating to get twice the bandwidth. And beam farming in the downlink. Beam farming is that moving your beam to the direction you want. Okay? So when you transmit here, your antenna is facing like this. When you're transmitting here, your antenna is facing like this. Okay? How do you do that? Not mechanically. You do that electronically. Right? Your signal is transmitted with such a phase and so on and so forth that it goes mostly in this direction. Yeah.
So what about the uplink?
Oh no, uplink is really very difficult, because first of all, you can't have 4 antennas or you multiple antennas, too many antennas in your phone. So the uplink is similarly in the downlink, where you have all this expensive equipment available to do beam farming. The feature list continues. You can get 326 megabits down, 86 megabits up with 20 megahertz and 4x4 MIMO. Of course, if you don't have 4x4 MIMO, if you don't have 20 megahertz, you won't get these rates. The modulation is QPSK, 64 QAM, and 16 QAM. So now we are getting there. Okay. OFDMA in the downlink. So now we are not doing FDMA or TDMA. Multiple access. That means that how do we share? Multiple users share the link using OFDMA. OFDM is modulation. OFDMA is the access method. OFDM is modulation, means that you divide into multiple carriers. That is OFDM. And OFDMA is that now you give everybody a particular time slot and a particular number of carriers, and you divide among all the users so that they can use it in parallel. This is like CDMA, but there is no code. Right? You're given a number of carriers and and the time. That is OFDMA. In the downlink, in the uplink, they changed. Now this is the main difference between WiMAX and LTE. Now I came from the WiMAX background. I spent 4 years working with WiMAX forum, and I saw that everything was stolen. Now this is my point of view. Everything was stolen by the LTE guys. They took the whole technology and they said WiMAX is no good because it uses OFDMA in the uplink, and OFDMA is not good for the uplink, and we need SC-FDMA, which I will explain in a minute. So they use single carrier frequency division multiple access in the uplink. That was the main difference. And then of course, WiMAX is now gone. It's no longer there. In my view again, because somebody will object to it. Every university has. Here, if you read the papers today in the academic literature, they are still writing papers on WiMAX. I stopped writing in 2009. The day I knew that WiMAX is not going to be there, I stopped. WiMAX forum stopped after maybe 1 or 2 years after that.